Okay, you want to make a note of this because the instructions in the packet to me are a bit confusing. Problems 1 through 6 are all the same question. What they're doing is they give you a graph, and you can think of the graph they give you as being f, just some function. Then they give you 4 possible graphs. One of the graphs they give you is the matching f prime. And that's the same for problems 1, 2, 3, 4, 5, and 6. Memorize this statement. Every tangent slope on f is a y-coordinate on f prime. For example, right here on f, if I go to this x-coordinate, so just estimating, that's about x equal 1.7 negative. Okay, at that point on the graph of f, so here we are in f, if I were to look at the tangent slope on f, I find a tangent slope whose value is 0. So the tangent slope of f at x equal negative 1.7 is 0 in this case. What that means is on the corresponding graph of f prime, because f prime is known as the derivative of f, the y-coordinate of f prime must be 0. Okay, you don't need to memorize all those words, but you have to memorize the idea. I look here on f, I actually find it here as well, and here as well. I find tangent slopes that are equal to 0. So if I were making a chart, I'd say, okay, tangent slope of f and then I also know y-coordinate of f prime. So here at x equal negative 1.7, tangent slope of f is 0. That means on f prime, the y-coordinate must be 0 at that same x. The same is true when x equals 0. Tangent slope of f is 0. That's right here. Therefore, at x equals 0 on the graph of f prime, the y-coordinate must have a value of 0. And then same thing at x equal 1.7 on the graph of f. Tangent slope is 0, so the y-coordinate on f prime must also be 0. That's how f is connected to f prime. That's what derivative means. The derivative of f is f prime. That connection is through the tangent slopes of f. Anybody need me to talk more about that so far? Okay, we're supposed to find a match. For this particular problem, they've created a situation where that doesn't help, because this y-coordinate on f prime at x equal negative 1.7, this y-coordinate is 0. That's a perfect match for this right here. Tangent slope on f has a value of 0, means down here the y-coordinate on f prime at that same x has to also equal 0. Question? So, doesn't work here, doesn't work here. That clue will be helpful in other problems, but it's not helpful in this problem. Questions from anyone? Oops.
Yeah.
It doesn't help if you mark the wrong spot. Sorry, I got distracted waiting to see if there was a question. I was meaning to mark here. There we go. Question. Please, Cameron.
Yeah, sorry. I have no idea what any of this is.
Ticket for bravery. Good work. No, seriously, the whole point of the class is make sure it makes sense. So keep speaking up. Okay, so what we've studied in the previous packets is we started trying to learn what is meant by f versus f prime. Okay, so we talked a little bit in previous packets about that. The connection is the following. You take a graph of f, everybody eyes up here. You take a graph of f and you go point by point along f. You can find a tangent slope at pretty much each and every point of f. So what I did here is I just found the easiest tangent slopes to identify. Those are where the tangent slope is horizontal. So that tangent slope at this x-coordinate definitely has a tangent slope of 0. Does that feel okay?
Oh, yes. Okay. Yeah,
You good so far? No worries. Just keep talking. So I've got that. Okay. The symbol f prime. Everybody, make sense of this. It's like there is no more crucial idea than anything else we talked about all year. So if I were to make a chart and say, okay, I'm going to follow this graph of f, and I'm going to make a note of each and every tangent slope of f. So far I've only done it for 3, but I could do it for every point on f. If I were to do that, and then I take these values here, these tangent slopes of f, and I plot them on another graph as y-coordinates, that other graph is what's known as f prime. It's known as the derivative of f.
Oh, that's what those options are down there? That's like
Perfect, perfect. So in this problem, they're saying, okay, here's my f. One of these is a match. Like one of these is the f prime that goes with this f. And so far, all 4 seem to work. Because the tangent slope on f at x equal negative 1.7, x equals 0, and x equal positive 1.7, those tangent slopes on f all have values of 0, which means the y-coordinates on the correct matching f prime graph must also be 0 at those same x-coordinates. I don't know if that helped at all.
Okay, yeah, that's good.
Better? Cool. Don't hesitate to ask. So anybody else? Awesome. So continuing that theme, everybody look here. Okay, I'm going to do one thing that I typically wouldn't do because I want to make sure we're understanding the big idea. So this is more of a make sure this concept makes sense. As far as solving the problem, I don't typically take this approach. But following up with Cameron's question, if I go right here at x equal negative 2, and I do my best to draw a tangent line, that tangent line is going to be very steep and very positive. That's a good tangent. Would you not say that's a good drawing?
That's really good.
Thank you. I appreciate your positive feedback. I can always use this. So, class a little dead this morning. Okay, that tangent slope is very, very positive at x equal negative 2. So again, chart over here. So here I am at x equal negative 2. I know my tangent slope of f is a very positive number. That means my y-coordinate on f prime must be a very positive value. So let's see. At x equal negative 2, this y-coordinate is like negative 3. That is completely wrong. These y-coordinates must match the tangent slopes of this graph if this is going to be the correct f prime that goes with this f. See, the word derivative means derived from. So this is derived from this. So whatever these tangent slopes are, that must be these y coordinates. That's a big mismatch. Question. Awesome. Look here. This one also does not work at all. That's a very negative y coordinate, like maybe negative 35. But I need a positive y coordinate to match this positive slope. This looks a lot better. This y coordinate, this is at x equal negative 2. Y coordinate looks to be about 35. This is my possible graph of f prime, which means up here on the graph of f, I expect to see a tangent slope right here of 35. Seems reasonable at least. Questions? Cool, that's the big idea. When I'm looking for a match, using Danica's chart sometimes is a little bit quicker. I can say right here, from x equal negative 2 until x equal negative 1.7, the graph of f is increasing. So the correct matching graph of f prime must have positive y coordinates. Here's a problem. We already know this doesn't work. Here's another reason why this doesn't work. These y coordinates are all negative. I need a graph whose y coordinates are positive on that interval. Because this interval from negative 2 to negative 1.7 on f, the y coordinates are going up. Therefore on f prime, the y coordinates must be positive. These are negative. This is definitely wrong. Same thing here. These are okay. Positive y coordinates. So that one still works. Positive y coordinates. Question. Whew. Cool. So we're down to two choices. Just keep going. Up here, this graph of f has y coordinates that decrease. And these y coordinates decrease from x equal about negative 1.7 till about x equal, that's good tracing. I'm very happy with that. Much harder than it looks. I know it's nothing to be proud of, but whatever. So, if on f, from x equal negative 1.7 until x equal positive 1.7, f is going down. That means all the corresponding y coordinates on the correct f prime graph must be negative. We'll pick points to the whole room. Here's how you vote. If you feel confident that the correct answer is C, you're going to vote like this. C. If you feel the correct answer is D, you vote like this. Just go like this, so everyone else can't see. Just show me. So if you think C is correct, you go like this. If you think D is correct, go like this. It doesn't matter if you're right or wrong. It just gives me a chance to see. It's always better to vote than not vote. If you just don't know, go like this. Then I see that I've got to do a better job of explaining. Everyone give yourself 2 points for voting. Okay, like I was saying to Cameron, another point for him. It's all about understanding that f prime is the derivative of f. That means f prime comes from f. So I'm paying attention to characteristics of f, and I'm trying to find an f prime graph that has the appropriate matching characteristic. So what I saw was, starting at x equal negative 1.7, until I get to x equal 1.7, the graph of f here decreases. Saying that f decreases means I see f going down. Therefore, the matching graph of f prime must have only y coordinates whose values are negative. So just say it out loud for a second. Here's a possible graph of f prime. I start here at negative 1.7. I follow the dots. Say it out loud, please. Is this y-coordinate negative or positive? Say it.
Negative.
This one?
Negative. Negative.
Well, that one's 0, so that's a little confusing. This one?
Negative. Negative.
Okay, come over here. This y-coordinate is?
Negative. Negative. Positive.
Yeah, that's the problem. From x equal negative 1.7 until x equal 1.7, if I have f y-coordinates that go down, I must have f prime y-coordinates that are always negative. This is matching up pretty well. The 0 is a little confusing. This doesn't match at all because of this section where the y-coordinates are positive. Question? Please, Cameron.
So the positive 2 tangent, would that one also be positive?
Right here?
Yeah.
So if I look at that, that slope is definitely positive and very steep. That works out just fine. Because right here, this y-coordinate is at, sorry, the x is at 2, y-coordinate's about 35. That's a good match for that. Does that make sense? Good point. Everyone else, enjoy the mowing. So. Everybody needs a mower like that at home. Thing that really moves. Question. Please, Matt.
Does the y-axis matter? Like, because I was like on that one, it's like up to 35, and on this one, it's only up to 4. Do we need to look at that, or are we just looking at the pattern of the graph?
All eyes here. 2 points for Maddie. They do have to correspond, but because that takes longer, I kind of leave that for my last check if I have to. I found that these problems are actually quite common on the AP test. And usually, if I start with identifying where do I see tangent slopes of f that have tangent slopes of 0, I start there because they're easy to spot. And it's easy to see on the graph of f prime y-coordinates that are equal to 0. That's my starting point. Then I just work my way down Danica's chart, checking for a correspondence. I don't worry about any numbers. And that, about 95% of the time, will solve the problem. Once in a while, and we'll show an example next, actually, where this happens, I do have to look more closely at the numbers.
Okay.
But it's not common. So, is that your question?
Yeah.
2 more. Anybody else? Cool. So again, 1, 2, 3, 4, and 5, same idea, just different problems. Now, 7, 8, 9, and 10, they're going to switch on you. So make a note of this so you don't have trouble in the future. 7, 8, 9, and 10, they're giving you a possible graph. They're giving you a graph of f prime, and they want you to work backwards. So they give you f prime. You have to go figure out which one could be f. They're asking you to work backwards. Reagan, question?
You just have to know that that's correct. Like, you don't have to say that. Like, you just know that.
Yeah, I'm with you. Let me show you something that might help a little. So right here, I copied and pasted the words for problem 6 compared to the words for problem 7, and they're nearly identical, which makes it hard. It says, which of the following graphs, A through D, so they're saying, you know, which of the graphs below could represent the slope of the, at every point, of the function graphed, like at the top. So on number 6, they're saying, take this graph, find the slope at every point, graph those slopes here, and which one matches. So that's how I know that this is f and this is f prime. Now 7 through 10, they switch the wording on you. They say which graph below could represent the function whose slope at every point is graphed here. So they did reverse it, but it's not worded well at all. So that's why I'm saying, just remember this is f prime, this is f.
Okay.
Is that your question?
Yeah.
2 points. The AP wording is usually much more straightforward, honestly. This one's a little weird.
Could you just tell us which problems are switched?
What's that?
Could you just tell us all of them?
Yeah, so 1 through 6, it's always, so 1 through 6, they're giving you f, you find f prime. 7 through 10, they're giving you, so here's 1 through 6, they give you f, you find f prime. 7 through 10, they're giving you f prime and you find f. But the wording is kind of confusing. I totally agree. So, anybody else? All right, you want to start in the same place, but you have to think backwards. So on number 6, we started by looking at f and identifying where on the graph of f did I have a tangent slope whose value is 0. Well, now we're looking at f, and then we said, okay, because the tangent slope on f here is 0, the y-coordinate at that same x must be 0 on f prime. Now we need to do it backwards. So I want to check the whole room. Feel free to talk to each other if you want. Raise your hand if you can tell me at what x-coordinate am I going to look first here. Like on this problem, the x-coordinate I looked at first was negative 1.7 and 0 and 1.7. Now I'm doing it backwards, so raise your hand and tell me at what x-coordinate am I going to look first here. Show me hand. Always better to raise your hand and be wrong than not raise your hand, I guarantee it. Because if I call on you and it's incorrect, you still get points. Plus, by just saying what you thought was right, you actually learn better than just by waiting. So Emma, what do you think?
Would it be 3, 0, and -3?
So Emma's looking here. Is this weird looking, Emma?
Yeah.
No, you're fine. 3 points. So this would be like 6, -3. 3 points for Emma. I can start there, but it's actually a little bit harder. Because here, helps if you label it correctly, sorry. How many saw the mistake? Show me hand. 2 points. Yeah, it's supposed to be 0.3. I was thinking as I was writing this. This is a negative. Everybody good? Okay, you can start there, look at me. But it does make it harder. Because this is telling you, this is the graph of f prime. And this is saying, at x equals 0, on the graph of f, we should find a slope of 3. And honestly, maybe it's not a bad way to start. It's just not the way I typically start, but it doesn't mean it's wrong at all. So I go right here. This is a possible graph of f. I go to x equals 0, which is right here. And I should find a tangent slope whose value is 3. That's how f is related to f prime. So, raise your hand if you had your hand raised a minute ago. Give yourself 2 more for Emma. I want you to vote. Oh, please, Charlie.
Well, can't you just see that f prime is decreasing the whole time, so you can cancel out A and C?
So what Charlie does, he says, okay, skip looking at points on this one. I see f prime here. The y-coordinates are always going down, which means if my f prime is always decreasing, my f should always be a concave down shape. Let's follow Charlie's reasoning for a minute. So if f prime is always decreasing, like we see, my f should always have a concave down shape. Raise your hand if you know which answers are possibilities at this point. Let's go, Allie. So Allie goes here. B and D are always concave down. C is actually as well. So this is a concave down shape. This is actually concave down, then concave up. So that doesn't work anymore. 3 points for Allie. Show me your hands. We have them up. There you go. 2 more points. No, you can't do that, Charlie. There's nothing wrong with it. In fact, really, solving these matching problems, there's not a magical sequence. There's a sequence I kind of like. Like what I was going with Emma, there's another point for her, is this is a mismatch. That says the y-coordinate on f prime is 3. So the tangent slope here on f would have to be 3. That's definitely not a tangent slope of 3. So that would eliminate A as well as a possibility. Question? I would have started looking at a different point up here. Raise your hand if you think you know which point I would look at. Okay, for everybody. Again, always better to raise your hand. Better to be wrong than just be quiet. I promise, it really is. Nick?
X equals 3.
So I look here. That's x equal 3, y equals 0 on the graph of f prime, which means on the graph of f at x equal 3, I should find a tangent slope of 0. So here, that's not going to work. At x equal 3, this tangent slope is not 0. However, here, x equal 3, that tangent slope is 0. 3 points for Nick. Show me your hands if you knew that. 2 more. Question? Okay, so don't need to look here anymore. Let's see, we checked. We've got this checked already. Got that checked. We could look here, I suppose. We could say these y-coordinates of f prime, so these y-coordinates of f prime are all positive, which means the corresponding graph of f should be increasing on that interval. But unfortunately, both of these are increasing on that interval. So that didn't help. We could say here f prime has negative y-coordinates. So f should be decreasing on that interval, but both are. Doing some fine tracing today. Very happy with that. So. The little victories in life, you savor when you get old. All you got left. Questions? Cool. So none of that helped. So I've got to find some other way to find a match. I know it's one of these two. And honestly, with the AP test and you're stuck, guessing is not a bad option at that point, I'll be honest. If you get it down to 1 out of 2, it's a pretty good chance. Take your best shot, move on. However, we'd like to know how to find it. Any ideas? Hands up. Okay, everybody. Let's go, Ainsley.
Well, you said something about the slope at the beginning, and so it's 0, 3, so it would be D because at 1 it's 3. I think, I don't know.
You're doing just fine, Ainsley. It's the fundamental idea. Everybody, got to get this one like locked in solid. We'll use it so much all year. This graph of f, if I look at the tangent slope here, I see the y-coordinate here. If I see the tangent slope here on f, I see the y-coordinate here. So tangent slope here, missed. Come on, try again. A little low. We'll be here for 5 minutes. Okay. That's decent. I'm liking that quite a bit, actually. This one's harder, steeper. Shoot. Come on. Well, you know. It's, no, brother. Oh, the pen didn't work. It was perfect. Whatever. I can't quit. Okay, one more. There we go. Sweet. No, she's got it. Look. Wow. Rise over run. That thing's going up 1/2. It's going over 1. So that slope is 1/2. Tangent slope equal to 1/2. That's not a match. It's supposed to be a tangent slope of 3. Here's pretty good. I can't draw it perfectly, so I can see I'm off a little bit, but definitely much better than that one. So, how many noticed that before I did all that nonsense? 2 points. Okay, 3 for Amy. Question? Please, Cameron.
So one thing like that you could maybe figure out is that like, so you notice how like B, it just says it's going up to 1, and then you see the F prime and it's going up to like 3 or 4 or something like that. That's one thing to look out for, is like if you can't figure it out and you have to narrow it down to those two, is that like the one like D is like up to scale more because it's like going to 3 at least.
Not a bad observation. I wouldn't honestly be totally comfortable with that, just for fear that they would get very clever on me. I'd look a little closer just at a given point. But I like your thought. 2 point. Next one. Go to number 12.
Can I ask a question about last?
Oh yeah, please.
So I'm just confused because isn't the slope on the top, is that a slope of 1? On that top?
Like this entire slope here.
Yeah.
All eyes up. Look. Hey, take it for Maddie. Listen close while she's getting a ticket. Okay, the key link is this. Every tangent slope that I see on F prime, that gets plotted as a y coordinate here. With me? So like here, my tangent slope at x equals 0 is 3, so my y coordinate x equals 0 on F prime is 3.
Oh.
If I look at the slope, look at me. If I look at the slope of F prime, that slope goes, Maddie saw it, goes over 3, down 3. So that slope is always 1. That's telling me what the graph of F double prime will look like. Because F prime is the derivative of F, meaning F prime plots the slopes of F. F double prime is the derivative of F prime, meaning F double prime plots the slopes of F prime. So my graph of F double prime will look like this. Where every single point on F double prime has a y coordinate of -1, because every single slope on the graph of F prime is -1. Is that what you meant?
Yep.
Perfect.
Thank you.
There you go. Cool. Go to 12. Somebody the other day, they kind of missed my little opening statement about how this class is very different than most previous math classes, where you'll learn a topic for like 3 weeks and then you kind of set it aside. You don't really use it again for the rest of the year until maybe the final. Calculus is not like that. These connections that I'm showing you now will get tested on them in the first test. For the second test, we do take a tiny, tiny break for like just 2 or 3 weeks, then right back into it. You have to remember it again. So make sure this makes sense. You can't just set it aside. Okay, it says in figure 220, the second derivative at points A, B, and C is what? So what they're saying is, think of a chart. And we're looking at F, but we're trying to figure out what would be happening on a graph of F double prime. Because F double prime is the second derivative of F. F double prime is the second derivative of F. please be careful. F double prime is also the first derivative of f prime. So it's relative. It's not like f double prime is always the second derivative. It's the second derivative of f. F double prime is the first derivative of f prime. Questions? Okay, what I notice is that x equal a, if I'm comparing these two, Danica's chart tells me what I should be thinking about. It's right here. The only connection between f and f double prime that's easy to see is the concavity of f compared to the positive or negative of the y-coordinates of f double prime. Listen closely for when I say y-coordinate versus x-coordinate. It's crucial that you keep them separate. So I notice at an x-coordinate of a, on the graph of f, f has a concave down shape. That tracing is a little sadder, but you know, more sad. So that's concave down on f. Danica's chart tells me, therefore, the y-coordinate, these are the y-coordinates of f prime here. The y-coordinate of f prime must have a negative value. Questions? If I go to point C, we'll skip B for a second. If I go to point C, I notice on f itself, f is concave up. So, on f double prime, the y-coordinates will be positive. At x equal b, f has what's known as an inflection point. We talked about that in the previous packet, meaning the concavity of f is changing from concave down to concave up right there. Look at Danica's chart. If f is not concave up or concave down, f prime can't have positive y-coordinates or negative y-coordinates. Therefore, the y-coordinate on f double prime at an inflection point on f is likely to be 0, although it could be undefined. Questions? So, correct answer is B. The second derivative at x-coordinates of a, b, and c would have these values as the y-coordinates on f prime. Question? Okay, go to 15, please. Okay, similar problem, but slight difference. We've got a graph of f here. Now they want us to look at f at only one x-coordinate, x equals 0. So I'll do my little table. But they want to know what are the y-coordinates of f, what are the y-coordinates of f prime, and what is the y-coordinate of f prime, and what is the y-coordinate of f double prime at specifically an x-coordinate of 0. So it's, again, you're being tested on how do the three relate to each other. So because this is a graph of f, I go to x equals 0 right there. So I note that's x equals 0, I don't know, y equal about 0.3. That's definitely a positive y-coordinate. Done. Questions? Now I look at the tangent slope of f, because the tangent slope of f is the y-coordinate on f prime. So that tangent slope, right there, that tangent slope is negative. Done. Questions? Cool. Now I need to look at how f relates to f double prime. So right here, F is concave up, so the y coordinate on F double prime would have to be positive. Question? Yeah, please.
How do you know when to do like tangent slope and then concave up, like for F prime and F double prime? Like, why can't you do like tangent slope on F double prime, for example? Like, how do you know when to do each one?
Gotcha. No, 3 points, Nick. Really well phrased question. So the first check I'm using is simply a memorized fact. I'm remembering that if I go to F and I go to x equals 0 and I measure this tangent slope. Now for our class you won't typically measure, but I'll do it here for a second. So I measure that tangent slope of F at x equals 0. And what I find is, best I can estimate, looks like I'm going, let's see, it's not quite 1, it's more like kind of down 2 over 3-ish kind of a thing. So about negative 2/3. That means if I were drawing the graph of F prime, and I went to x equals 0, I would have a y coordinate of negative 2/3. With me?
Yeah.
So that's where I got this. I didn't need any numbers for this problem because the question only asked for positive or negative. So I simply looked it up, saw that this tangent slope is negative. Now I'm done with that part. Now, the next jump from here to here, I really can't see that easily. All eyes on me. You'll have some people, I promise, that will try to teach you to draw things out to get from here to here. There's nothing wrong with doing that, but it's a lot harder, and it's very mistake prone. So I'm not saying that's wrong, but I am saying it's a lot more difficult. For the AP test, for our class, you don't ever have to really do that. You just have to know this relationship right here. If my graph of F has a concave up shape, my graph of F double prime is going to have positive y coordinates. That's all I have to do. So I don't really know what F double prime looks like, and I don't typically worry about it. I just know that at x equals 0, there'll be a dot somewhere on F double prime that is positive. I don't really know how positive. Does that help at all?
Yeah.
2 more, Andrew.
So if you went the line of F prime, it's a negative, like we were saying. But if you go to Danica's chart and you have the F prime, like the negative, it's not, or like it's decreasing, so F double prime would be negative. So you just have to go straight from F to F double prime. You can't do it through F prime.
Let me say back what I think you're saying, 3 points. Are you noticing, and just talk to me so I can help answer your question, are you noticing that this line here is decreasing? And so is that leading you to think of this right here?
Yeah.
Awesome. Everybody look up. Look at me close. That's really, it's like an outstanding question, so I'm paying you. It's a misunderstanding. So it's no big deal, but it is a misunderstanding. This tangent line, that tangent line is definitely decreasing. That doesn't mean F prime is decreasing, because F prime is not the tangent line. F prime is a bunch of other dots whose y coordinates represent the slopes of this. So because I don't really have a picture, so I don't have a picture of F prime at all. I have a picture of this tangent line. It's related but different. So I can't make that conclusion without, if I could see F prime, then I could make a judgment. Does that make sense?
Yeah.
Yeah, the tangent line is not F prime. Does that help a little? It's good work. Please.
So when you looked at the tangent line, you just said it's negative slope, hence F prime is negative.
At that one point.
At that one point. But also you could go back to Danica's chart And if you look at F and look at that point, look what the graph itself is doing. The graph itself is decreasing, which therefore F prime, if you look down at this chart, F prime is negative.
Also works perfect. Yeah, that's perfect because you can see F itself. I can see that F is definitely decreasing. So even though I can't see F prime, I know the y coordinates on F prime have to be negative. But that's not from looking at the tangent line. Perfect. Anybody else? 3 points for Mr. Rucky. Cool.
Yeah.
Awesome. No, really awesome comment. Anybody else? Perfect. We're done with this one. Go to number 22. Nope, sorry, 23. There we go.
Wait, 22 or 23?
23, my bad, sorry. 23. This is the first time I've shown you in class an actual AP test. Question. All the other questions have come from a book or something I invented, I think. Yeah, I don't think I've given you any real AP questions yet. This is the first one. You can always tell when I give you an AP question because I like to keep track of where they came from. So don't let the packet confuse you. It's number 23 in the packet. But in 1985, that's a while ago, I was a sophomore at BYU. This test question was given on the AP test, and it was question number 43. That's why you see two numbers. So don't let that throw you. It's no big deal. All right. Huge caution. Don't read AP questions quickly. If you do, it'll seem like you're reading something familiar, and you'll make the mistake of thinking it was like some other question. It won't be. They do it all the time. They give out a question one year, the next year it's just enough different that if you read it quick, you'll mess it up. So always go really slow. It says F. That's important. I'm talking about F. I'm not talking about F prime or F double prime. F is a function that is continuous. Make sure I note that. On the closed interval, -2 to 3. I noticed something there. All 5 answers are graphed on the interval -2 to 3. So that clue doesn't seem to be very important. That's not too atypical, so keep going.
Wait.
Oh, please.
Wait, wouldn't B, I'm at D, not be continuous because it's like split up or something?
D has a jump for sure, from here to here. So it says which of the following could be the graph of F? 2 points for Cameron. We have eliminated D. It says F must be continuous. Which of the following can be F? D is not continuous. Perfect. Question. Keep reading. Such that F prime of 0 does not exist. You need to write something in your notes. You need to memorize this. F prime exists if 1, F is continuous. 2, F has no corners. Or vertical tangents. So this problem is saying at x equals 0, see, what they're asking you to do is translate the symbols and show that you know what they mean. This is saying at x equals 0 on the graph of F, it says F prime of 0 does not exist. Well, F prime can only exist if F is continuous and F doesn't have a corner or vertical tangent. Vertical tangent is where the slope goes straight up.
What does it mean by a corner though?
Corner is where the slope changes abruptly. So on a curve like this, even if the curve is very steep, I think of it like the Earth. The Earth is round. Don't believe the flat earthers. Okay? The Earth is round. Sorry, I believe, never mind. The Earth is round, but if you get really, really close to that curve, it seems flat. But if you have a corner like this, no matter how close you get to that corner, it is always a corner. Like it's always an abrupt change in slope. So this is not a corner, here's a corner. An abrupt change in slope, stuff like that. So I'm hurrying just a little bit. So I'm looking for, let's see, it says f prime of 0 does not exist. That means f either is not continuous at 0, or f has a corner or vertical tangent at 0. So these are okay. These have corners at x equals 0. This one we've eliminated. This one is a problem. Right here, f prime of 0 does exist. Because f prime of 0 means the tangent slope of f when x is equal to 0. This is a valid tangent slope. I cannot find the tangent slope on these three at x equals 0. Notice how often I keep reminding you we're only looking at x equals 0 right now. So, questions? Keep going. Sorry, we're in a hurry. F prime of 2 equals 0. That means the tangent slope of f when x is 2 must be 0. So go to x equal 2, check the tangent slope. That looks good. That looks good. Done with this one. That one didn't work. Dirty rats. Yeah, the AP test writers are sadistic. Give you a clue that doesn't even help. Whatever, move on. Last clue. F double prime is less than 0. That is the mathematical way of saying f double prime is always negative. Danica's chart to the rescue. If f double prime is always negative, f must always be concave down. This is the only one that works. Question. Sorry for hurrying. Jonah.
You do that
Go ahead, Jordan. Yeah, sorry, Jacob. So, are you okay, Jacob, that this clue is telling you that everywhere except x equals 0, the f double prime values will be negative? Okay with that? Danica's charts, my little memory aid, to remind me that if my y-coordinates of f double prime are always negative, that means the graph of f, which is what I'm looking at, must have a concave downshift. Did that answer your question?
Oh, wait, so,
Go ahead, Jonah.
so everywhere has to be the concave down, not just.
Right,
Except
right. Because it says f double prime is negative everywhere except x equals 0. Right there. So here f definitely concave down for all those x's. Here f also definitely concave down for all those x's. You good?
Yeah.
3 more. Pretty obvious. Okay, we got 2 minutes. Go to number. $28. I'm a little short on time, so I don't want to race because it'll slow me down a little bit. I apologize for rushing. It's the year of COVID where we just don't have as much time. Okay, we talked about this idea previously. You've got a moving particle. Please don't forget. They'll tell you the particle moves along the x-axis. I prefer to say it moves along some x-axis. So it's just moving along a line. So remember, here is the particle right here. Okay? These graphs do not show the particle. The graphs show numbers, and the numbers tell me about the particle. So look at this number right here. That's 0, 2. That means at time 0, the particle is located along this line at location 2. Right there, when time is equal to 0. That's what this graph is telling you, because this is a graph of the particle's position. They will use the symbol s of t sometimes to indicate position, sometimes x of t. They just go back and forth. Don't ask me why. That's what they do. So, this is a bunch of numbers telling me about this. This graph tells me the same thing. At time equals 0, the particle is at location 2. This graph is a problem. I can't even tell if this graph actually comes over to here or not. I don't really think it does, but this would be 0, 0. Same with this one. If I kind of make an assumption that it's this kind of a graph, I don't know that it is. This would tell me at time 0 the particle is right here, which is not true because it says particle starts from rest at the point 2, 0 on this line. It doesn't say the particle starts here at, that's the point 2, 0 on this graph. The particle is not here. These are numbers telling me about the particle. Particle's over here. Don't leave on the belt. So I know it's one of these three. I know it's one of those three. Because they're at least telling me the particle is starting at time 0 at location 2. Okay? Next clue says the acceleration is always constant and positive. Acceleration versus position. My acceleration is always positive. My position graph must be concave up. That's why this is the only one that works. You can go. After you have a question, go ahead, Jim.
Acceleration
So the way you want to remember it is acceleration is the second derivative of position.